video is going to go through and explain what is direct variation and partial variation. Example 1. Brandy drives from home to Niagara Falls. She drives 25 kilometers every 15 minutes. Complete the chart and then graph the data. So here's our chart with our independent variable being time and our dependent variable being distance. So our first differences are calculated based on our dependent variable, so our distance. So I'm going to subtract this way. So 50 subtract 25. And I'm going to subtract again. 75 minus 50. And I'm going to subtract again. 100 minus 10, 25. And 125 minus 100. And 150 minus 25, 125. So you'll notice all of them are 25. Okay. That we already know. When the first differences are the same, that means this is going to be a linear relationship, meaning it's going to graph in a nice straight line. So let's graph the points. When time is 15, distance is 25. When time is 30, distance is 50. When time is 45, distance is 75. When time is 60, distance is 100. When time is 75, distance is 125. When time is 90, distance is 150. Okay, so here we notice all the points line up nicely, and my line of best fit goes through it. A nice line with all the points on the line. Okay. So that tells us to determine the rate of change. So we know rate of change from previous videos is the change in x versus the change in y. So I can pick any 2 points and do the rise versus the run. So I go from, I'll just pick these 2 points. So here to here, and here to here. So this is my rise. This is my run. From 25 to 50, so that's a difference of 25. So 50 minus 25 equals 25. And so remember, I'm just looking across to find that numbers. And the run, let's go downwards. It's 30 minus 15, which is 15. Okay. So rate of change, also known as slope, is equal to rise over run which is equal to, in our case, 25 over 15. Or approximately 1.67. Okay. Talking about kilometers and minutes. So this is kilometers per minute. So what the rate of change represents here is they're driving 1.67 kilometers per minute. Okay, so that's what it represents. She's driving 1.67 kilometers for every minute. What is the dependent value when the independent value is 0? Okay. So if I look here, this is where my independent value is 0. And my dependent value is 0 as well. So that's my origin. The dependent value, in our case, distance, when the independent value. Okay, so writing an equation is new for us. So write an equation for this relationship. So our distance is basically equal to 1.67 times the time, because for every minute we are going 1.67 kilometers. So we like to represent that with equations. So instead of distance, we're going to use d. So d is equal to distance. And instead of t, I'm going to use x. So x equals, sideways, time in minutes, and d equals distance in kilometers. So this situation we just looked at is what we call direct variation. It's direct because it goes through the origin. It's at 0, 0. So if you don't, when time doesn't pass, you don't go anywhere. So you're starting at 0 when your independent is 0. So that's a definition for direct variation. Oops. There's the definition. Should be here. Seems to be missing. Then we have what's called partial variation. Okay, so that's different. Okay. Now we're going to look at partial variation. That's when all the points lie in a straight line. The graph does not pass through the origin. See, so the previous graph, we see that it had started here at 0, 0, whereas this graph, it starts at 4. That makes it a partial variation. So this is the origin. It does not start there, does not pass through it. Okay, so let's look at our second example, which is going to be partial variation. In most sales positions, people receive a low base salary and collect commission for items that they sell. Justin has a job selling cars. His annual salary is $10,000. For each car he sells, he makes a commission of $500. So if you look here, if he sells 0 cars, he makes $10,000. every time he sells a car, he's going to make 500. So that means here he's going to make 10,500. Another car, he's going to add another 500. And another car, you're going to add another 500. So I'm just going to erase the comma, because in some cultures, commas represent decimals. So I'll just leave it as a blank. Okay. And so on. So this table is completed for us. We're going to graph this data. So 0 cars, 10,000. So here you see we didn't start at the origin. This is my origin. So it's not a direct variation. So then in 1 car, it's 10,500. 2 cars is 1,100. 3 cars is 1,200. And you're going to see it's going to go up in a straight line. So I'm just going to, oops, go off there. So 10,000, I'm going to graph the important ones. So I'm going to go to 4 and 12. 6 is 13. Eight is 14. 10 is 15, and so on. Okay. So you'll notice it's going to be a straight line for all the points. And it did not start at the origin. So we're going to say that this is partial variation because when he sells 0 cars, he still makes money. So he's not starting at 0, 0. The vertical intercept is, this is vertical. So that's my vertical intercept. We also sometimes call it a y-intercept. Okay. And it's 10,000. And it represents, if he sells 0 cars, he still makes 10,000. So basically his starting salary is 10,000. Okay. Find the rate of change. So remember, rate of change is rise over run. So I'm going to go to my graph, pick 2 points. I can choose the first and last, doesn't matter, any 2 points. So remember, this is rise, this is run. So here I have 10 cars. Here I have the difference of $4,000 between 10,000 and 14,000. So rise is 4,000, run is 10. Rise divided by run. So this was 4,000. Did I have the wrong number? Oh, whoops, that should be 5,000. This was 15 here. Okay, so that should read 5. So 5,000 divided by 10, that's $500 per car. So this means that for every car he sells, he makes 500. So going back to Justin's salary equation or income, so his income is always going to be how much he makes. He starts at 10,000 plus he makes $500 per car times the number of cars. We're going to change this to variables. So I'm going to use I for income. And let's use X for cars. So it's going to make 10,000 plus 500X. So I'm going to add a question here. How much will he make? Sells 20 cars. So I equals to 10,000 plus 500 times 20, which is 10,000 plus 10,000, which is equal to 20,000. So we use the equation to find out. We know that X is our number of cars, so we sub in 20 for that, and we calculate it. So therefore, he would make $20,000 for 20 cars. Okay. There was our direct variation. Don't understand. All right, so let's keep going. The school is planning an athletic banquet. The banquet hall charges a fixed cost of $750 plus $50 per person. So whenever you have a fixed cost, you automatically know it's partial variation. So this is going to go here. Okay, because even if you invite no guests, you have to pay $750. Then you add $50 for per person. So I'm not going to add 50 here. 10 guests, so 10 times 50. So I get a 750 plus $50 per person times the number that's there. That's 100. So I get 750 plus 500. So that's 1250. Then I would do 750 plus 50 times 20. Get 1750. Then I would do 30 times 50 plus the 750, and so on. I know it's partial variation because there's a fixed cost, as we said. Even when it's 0 guests, there's a cost, so this tells us there's a partial variation. Rate of change, I don't have a graph, but what I can do is I can pick 2 points and calculate the difference. Okay, so let's just write down the points here. I'll use the first and the last one. So slope is rise over run. I can also use the y2 minus y1 over x2 over x1 formula. So if you notice, this is going to be x1, y1, x2, y2. So calculate your difference between your y values. So 3250 minus 750 and 50 minus 0. Okay, so that's 2,500 divided by 50. That's $50 a person. Helps, you can write the units here so they help you at the end. Okay. So create an equation. So it costs us our fixed cost, which is 750 plus $50 times the number of people. So that's 750 and say cost of C plus $50 times, I'll use P. Okay, so when we create an equation, we can use that to calculate afterwards. So cost is equal to 750 plus 50 times 75. We have 750 plus 3,750, which is equal to 4,500. Therefore, it will cost 4,500.